This is Geometry, Unit 7, Day 15. We're working on the law of cosines. Recently, we've learned about law of sines, and with law of sines, we're making a proportion. You need to know both bits of one of the letters, the angle and its opposite side, and then, of course, you're working with another pair of dimensions, the angle and a side, one of which you know and one that you don't know. Well, with law of cosines, we're still going to solve for an angle or a side, but we don't have to know two bits of information on the same letter. So there's a set of formulas that we would use. It looks a bit intimidating here. Notice, again, whenever you do this, angle A and side A are across from each other. Angle B and side B are across from each other. Angle C and side C have to be across from each other. The formulas, if we're going to solve for A, we're going to use something that looks a little bit like Pythagorean theorem. A squared equals B squared plus C squared. But then we'll be minusing 2bc cosine of A. We could rearrange this so that the b squared was alone. Then the other two sides that are squared are the other two letters, minus 2 times those letters. And it's always cosine of what you're trying to solve for in the b squared. It's the angle across from b squared. C squared is going to equal the other two sides squared minus 2 times those same sides times the cosine of the opposite angle. So once you start to use this pattern, it can make a lot of sense. It's not that hard to memorize. So we're going to start out with a triangle. We're going to pick an A, B, and C. A is 600 feet. B is across from angle B, so it's 660 feet. And the angle we're working with is 50. That's for angle C. Notice we don't have two bits of information. This is called side angle side. That wouldn't give us 2 bits of information. Neither would side side side. So in both of those cases, we can use law of cosines. So they want us to find side C. To find side C, we definitely need to know angle C, because the formula to find side C, you needed to know angle C, and you needed to know the other two sides. So we can do that. C squared is going to equal A squared plus B squared minus 2 times those times the cosine of the opposite angle, which is C. So I don't know my C squared. My A is 600. My B is 660 minus 2 times that product times the cosine of 50. Well, using our calculator, we could type this right into our calculator, just the way it is. So we say 600 squared plus 660 squared minus 2 times 600 times 660 times the cosine of 50. So we put in that whole long bar together, So we're looking at 286,512.21. That's what c squared equals. So now we have to take the square root of that crazy number. And that's going to approximately, now notice how we're going to do that. We're going to hit the square root button, and then we'll say answer, and that'll bring the real value underneath the square root. So that comes out to be 535.27. So using a calculator, that makes it not too hard to do. Next, we're looking for segment BC. Segment BC is also known as side A. That's across from angle A. So if we're looking for side A, then we need to use the formula that starts with a squared, because we're looking for angle A. And then the other two letters squared minus 2 times those two multiplied together times the cosine of the angle opposite the side we're looking for. These are going to always match. These are not going to have A's in them because we don't know what A is. Okay, so A squared is going to equal B, so this is side B because it's across from angle B. 1.26 squared. Side C is 1.42 squared minus 2 times 1.26 times 1.42 times the cosine of our angle that's across from the side we're looking for. So you got to write that out. Now you can go through and solve that one piece at a time. Or we'll go to our calculator next. And we're going to say 1.6 or 1.26 squared plus 1.42 squared minus 2 times 1.26 1.42 times the cosine of 74. Be sure you're using cosine. Don't forget what you're working with and think you're working with sines again like we have in other lessons. So we're getting 2.6177. Then we're going to take the square root of that. We're going to keep the real value still in our calculator. We'll hit square root, come down to the answer button. So answer comes up underneath the square root. That takes the real value all the way across here. And that's going to give us 1.618. So that could, if we're going to round to the nearest hundredth like we typically do, 1.62. those are considered miles. Up here, these were considered feet. If we're given the units, let's use the units. Notice I don't just have an answer. You need to write all 4 of these lines when showing your work on homework or test quizzes. On the opposite side, we still have our law of cosines. You can take some time to write in your formulas again. Try to see if you can do some of them off the top of your head. When you're working with side A, so that's A squared, it's B and C that are squared, minus 2 times those values, and the cosine of the angle for the side you're looking for. Okay, what if we're given all 3 sides? Then we could find the measurement of an angle. So, the angle that's best to find using law of cosines is always the largest angle. Find the angle across from the longest side first. So first we're going to find the angle across from the longest side. We're going to find it first. So the longest side is 59. So we're going to find angle C first. So I'm going to start out with its formula. So we could use that, we could plug in all of our numbers, and then we could manipulate it. So, if I take my C squared, and I subtract my A squared over, and subtract my B squared over, and then divide by my 2 times AB, that's going to equal the cosine of C. So if we plug in our numbers, C is 5.9 squared, minus A is 5.4 squared. B is across from side B, or angle B. So our B is 3.7 squared. And we're going to divide this by a negative 2. Our A value was 5.4. So negative 2 times A, B. That gives us the cosine of C. Let's see what we get when we type that into our calculator. We're going to put parentheses here because we want to put parentheses around the entire numerator. You've got to know how to use your calculator. 5.9 squared minus 5.4 squared minus 3.7 squared. Put parentheses around that because that's the numerator, divided by the entire denominator. So let's put parentheses around that. So we use the negative 2 times 5.4 times 3.7 and close off your denominator. That comes out to be 0.2012. So we're going to get 0.2012. That is the cosine of C. So now we're going to say cosine inverse of 0.2012. That's going to get the measure of angle C by itself. So with our calculator, we're going to say second cosine to get cosine inverse. We're going to do that of the answer. And that's going to get us a 78.39. That's going to be the largest angle of all of these. You could go through and calculate the other angles in the same fashion. Once you get two of the angles, you can subtract from 180 to figure out the third. That's the process of how you need to do that. So this is our angle C formula. Our angle B formula would come from this. So it would be B squared minus A squared minus C squared divided by negative 2AC. That would equal the cosine of B. So you might want to write that down. And to figure out angle A, we would say A squared minus B squared minus C squared divided by negative 2BC equals the cosine of A. So now with those three additional formulas, that could make it a little bit easier for you to solve for an angle. You could plug it into the original problem and manipulate it, subtract them, square the numbers, and just work your way all the way to the cosine. That's how it's typically done. These formulas would help you. Three lifeguard stands are positioned as shown in the diagram below. The lifeguards would like to have a buoy line that would run from stand 1 to stand 3 for the non-swimmers. You keep the non-swimmers inside. Approximately how long would the line have to be? So some ways to do that. If it's difficult to measure across all this water, maybe we can measure along the edge of the beach. So the measurements that they've come up with here, if that's easy enough to read or not, we're going to have, we'll call that A, that B, and that C. Really doesn't matter what order you put them in. We already know this is supposed to be 140. This is 90. This is 85. That all came from our picture here. Notice that this is side angle side. That's one of the patterns that tell us that we have to use law of cosines for it. We want to figure out side A. So to figure out side A, we need to know what the A formula is. So to figure out A, we're going to say A squared equals B squared plus C squared, those are the other two sides, minus 2 times those amounts, times the cosine of the angle for the side which we're trying to find. So A squared is going to equal 90 squared plus 85 squared minus 2 times 90 times 85 times the cosine of 140. We can bring in our calculator and say 90 squared plus 85 squared minus 2 times 90 times 85 times the cosine of 140. And we get the value of 27,045. Now, careful, that's not actually yards. That would be a long distance. That is a squared. So now we're going to take the square root of that crazy number. And we like to call it approximately because it's not the exact value. It's approximately the square root of the answer. Don't just put in some of that number. Put in the answer to give you the whole real result. And you get 164.46. So that's how many yards it would be from one guard stand to the other. Last question. A hiker starts out at point A and proceeds 6 kilometers to point B. Here she decides to retrace her steps but mistakenly hikes along a path that is off from her original. She walks 9 miles. She is 4.84 kilometers from where she wants to be. What is the angle between her original path and that final path? The angle between the original path and that final path is this one right here. So in this case, we're given all the sides. So how do we solve for an angle? If we're given all the sides, we need to use law of cosines. Here we're looking for angle A. So we know we're going to use the formula A squared minus B squared minus C squared divided by negative 2 times BC. That's going to give us the cosine of A. We plug in our numbers. 9 squared minus 4.84 squared minus 6 squared over negative 2 times 4.84 times 6. That should still be the cosine of A. So using a calculator, you'll type in your 9 squared minus 4.84 squared minus 6 squared. Well, that should be in parentheses, by the way. Let's see. We could insert, if you know how to use your calculator, you can insert values. And so that's the numerator. Put parentheses around your numerator. Divided by, parenthesis, negative, not minus, but negative 2 times 4.84 times 6, and then close your parentheses for the denominator. and you should get a value that is actually negative in this case. We'll talk about what that means. So we got an answer to be negative 0.37146. So that becomes 1.5. Now, if cosine is negative, we've never had this before. We usually talk about it might be in radians if we get negative answers, but that's not this. This just means that the angle is actually bigger than 90 degrees. If you get a negative cosine, it's not that you've done something wrong. You can still do cosine inverse of negative 0.3715, and that's going to give us the measure of angle A. So we're going to bring in our calculator and say cosine inverse of the answer, so be sure to use the answer key, and that gives us 111.80. That's the angle between the original path and the path that finally brought her back.